So on this one, this is number 71, you might have been like, I don't even know how to start this. Well, if you think about the problem, they want to see, do colas lose sweetness after storing them? So it's a before and after. So let's just think about this for a second. Say you give the cola a score of 10, right? And no change, right? That means it would stay 10. If you subtract those, it would be 0. If they gave it a 5 and it stayed at a 5, right? It's equal to 0. I don't even know what the scale was, but I'm just saying, remember I always say null hypothesis is, think of it as no change. So if there's no change, if the before and the after should be 0. Now if it does lose sweetness, let's say, I don't know, you gave it an 8, and then after storing you gave it, I don't know, a 5, right? If you subtracted those, it would be a positive number. So that would be a 3. So it lost sweetness. Well, and then I guess opposite, let's say it tasted sweeter after storing. So let's just say it was a 7 and you gave it a 9. That would give you a negative number. So if you think about it, zeros would be no change. A positive number would be that it lost sweetness. A negative number would be that it actually increased sweetness. Okay, so there we go. We've got that stuff. So now we might be able to start this problem. So let's just get this out of the way. And here's our data. And let's see. What would be our null hypothesis? So the, where is it? The null hypothesis would be that the average would be 0, no change. And we're going to say that the alternative hypothesis is going to be that it is, the average is going to be bigger than 0, because a positive number indicates that it lost sweetness. So this is a t-test, right? It's going to be a t-test for, and we want to see, do colas lose sweetness over time after storage? And we're going to test this at an alpha level of 0.05 because it's not stated. So we're going to go with that. All right, now we can get started. Random. Was it random? Yes, it says it in the problem. Found by tasters from a random sample of 10 batches. Okay. And then independent, we're going to assume that there's over 100 batches. And let's see, the next thing is, independent. No, normal. So I'm going to put these values into list 1 and see what kind of a box plot they make. So this is what the box plot ends up looking like. Now, you might say it's skewed, but look at this middle section. This middle section is pretty big. So even though it's shifted over here, we can still use it because T procedures are fairly robust, except for extreme skewness or outliers. Wango. There we go. Now I'm going to write down the other stuff. I'm going to go into stat, calculate one variable statistics, and see what we got for that stuff. Okay, hold on a second. So for our list of 10 data points, there's the average for the sample and the standard deviation. So we're going to do the test statistic, or z-score, and what are we going to put? Let's see, 0.91 minus 0 for no change. What we observed versus what we thought it might be. And then the new standard deviation, which is 0.214 over the square root of 10. And what do we get for that? So it looks like we get 2.37. 2.37, quite a ways over there. Now, we're going to get our p-value. So we got to put this into normal t-CDF. And when I did that, I got So don't forget the degrees of freedom is 9, and I get 0.979. 0.979. But we got to subtract that from 1, don't forget. And we got 0.02. Okay. So, let's see. So at a 0.05 level, alpha level, it's too small, which means that if, let's do this one more time. If it really was no change, right? The storage didn't affect it, it was 0, and we got an average for a sample of 0.91, well, there's only a 2% chance that that would actually happen. So we're going to reject the null hypothesis in favor of the alternative hypothesis and state that, yes, we feel like the colas do lose flavor or sweetness over time. All right. Now, if you look in the back of the book, it says that the test statistic is 2.7, but I did the t-test in the calculator, and I'm getting the same answer that I got. So anyway, if anybody can tell me how they're getting 2.7 for the test statistic, go ahead and tell me tomorrow. Okay, let's do the next problem. Well, if you subtract that, you get 458.2. Now multiply that by 1.5, and you get 687. Now take that number and add it to Q3, and you get 177.73. Okay. Your higher number, the maximum would have to be bigger than this number for it to be an outlier. Well, the biggest number is only 1425. So we're good on outliers. There are no outliers, so that's kind of a review. Find the interquartile range, multiply it by 1.5, add it to Q3, and the maximum has to be bigger than that. Wango! Okay, now let's take a look at some of the other stuff. Man, oh man, look at this. So, well, the mean, the average is 856, standard deviation of 306.7. Wow, look at this. Negative 6.73. That is a lot of standard deviations, which indicates why this p-value is basically 0. So that's very strong evidence to reject the null hypothesis and say, yes, these women are not getting their RDA, recommended daily allowance of, what do they want? Calcium. Okay, so that's basically the whole problem right there. I think letter C, they want you to actually calculate, how did you get these numbers? So they give you all the stuff that you need to do. And there I just wrote it out for you. So it's our, what we got for our sample right there, minus what they say it's going to be, and their standard deviation divided by the square root of the sample size, that's n right there, 36 people, and that should give you your test statistic. And we could write out the null hypothesis and alternative hypothesis. Null hypothesis is that, yes, they're getting 1,200 milligrams. Okay? In fact, it shows you right here. Whoa, whoa, whoa. Look at that right there. There's your null hypothesis versus your alternative hypothesis. Okay. Sweet. All right, I'm done. Out.